Good morning, my dears. Today, I will discuss about the adaptations that can happen to a patient with a squint. Now, I will share my screen. Last class, I discussed about the methods to find out the phobias in a patient for distance as well as for near. Today, I'll tell you something about the adaptations, mainly the sensory adaptations. So, why should the eye get adapted? What's the reason in the case of squint? Because in a squint patient, they can have double vision, diplopia, and also confusion. There are two terms you're supposed to know. What diplopia? Outside world, one object is there that falls on the fovea of the normal eye. Because of squint in the other eye, it falls some other point in the retina. So from some other point, the object, when it falls on some other point, the image is projected outside world. Whereas normal eye also can see some image. The squinting also will see some image, but it's not so clear. False, that's called false image. That's called double vision. That single object is there. Patient sees two images. Whereas in confusion, what happens now? Patient has got squint agreed. But now the object, one object will fall in the outside world, will fall on the fovea of the normal eye. And another object is there. Another object is there in the outside world, which can fall in the fovea of the squinting eye. Naturally, that what happens, both images are falling in the foveas. So naturally, the patient gets confused. These called confusions. Never forget, exam question is what? What is diplopia? What's the difference between confusion and diplopia? Diplopia means an object is there, it's falling on fovea of normal eye and some other point on the retina of the squinting eye, projected outside world, there's two images. Whereas confusion, one object is falling on the fovea of the normal eye, some other object in the outside world can fall on the fovea of the squinting eye also, patient gets confused. To overcome that, to diplopia mainly, to overcome that, patient gets what? Adaptations. Classically, we can have sensory adaptations and motor adaptations. Okay. What are the sensory adaptations? The squinting image is there, that goes to my brain. It can get suppressed. That is called suppression. Suppression because of squint in the other patient. The image from the abnormal, the squinting eye, the brain gradually suppresses. It can be so many types of suppressions are there. It's an obligatory suppression, obligatory. That means what? Or facultative suppression. There are so many different types of suppressions are there. What is facultative? Only when both eyes are open, the suppression is there. When you close one eye, the suppression is relieved. Whereas obligatory means what? The squinting eye, the vision, it always obligatory. Normally it's suppressed always. In facultative, only when the both eyes are open, suppression will be there in the squinting eye. Whereas in an obligatory suppression, where even when the one eye is closed, the normally is closed, still the patient has got suppression. That is the suppression, obligatory, which is responsible for going in for, your answer is amblyopia. So prolonged suppression in a patient with a squint that can go in for partial loss of vision or diminished vision in the squinting eyes. That's called lazy vision. That's called lazy eye. You know that. Whereas one more adaptation is there. That's called anomalous retinal correspondence. What is anomalous retinal correspondence? Now imagine now the object is falling on the fovea of the normal eye. The object is falling on the other area, some other point in the retina, but some other point in the squinting eye will also have the same visual direction as the fovea of the other eye. That means they will have a crude binocular vision. The some other point will behave like a fovea for the fellow. There's a classical thing that's called ARC. That is, the non-corresponding points are there. Please remember, one eye fovea, other eye some other point. That some other point become like a corresponding point for the normal eye. So that the same single object can be seen. But it is not so clear. No, it's called a crude binocular vision. And your important point, never forget here, when you cover the normal eye, when the patient got abnormal delta correspondence, ARC, when you cover the normal eye, the abnormal eye, that's called squinting eye, will take a foveal fixation. That's the most important point you are supposed to know. When you cover the normal eye, the ARC eye will take a foveal fixation. That is, the abnormal point has then become fixed. It has not become completely fixed for the fellow. That is why the fovea still is working for him. That's a classical difference you are supposed to know. What for the suppression is there? I told you, to avoid diplopia and confusions. Okay, it occurs where in a patient squint and also anisometropia, the different refractive errors or refractive powers in both eyes. I told you facultative and obligatory. Obligatory means I told you what? It occurs under all conditions and remain even when the nominal eye is covered, normal eye is covered. That is the reason for your amblyoppias. Now, here also one question will ask you, suppression. Do you know one condition called blind spot syndrome of Swan? Blind spot syndrome of Swan. Classically, it occurs in, I tell you, suppose I'm having one eye squint is there, convergence squint is there. Understand now? About 30 degrees or 30 prism diopters, not 30 degrees, 30 prism diopters or 15 degrees approximately. Esotropia is there. The object is falling on the fovea of one eye. Okay, and this object, one object is falling in the fovea of one eye, normal eye, and it falls on the blind spot. That is what? The optic disc level. So the object from outside world falls on the optic disc area, which is not coming to the picture at all. The object, patient will not appreciate that object in that squinting eye. That can happen to whom? A patient with the esotropia, about 15 degrees or 30 prism diopters, they can develop. That is called blind spot syndrome of Swan. He described in 1949 about those conditions. Now, how do you find out suppression? How do you find out abnormal correspondence? There are some tests. Just know that Worth-4 dot test. What is Worth-4 dot test? You are having a right eye red color goggles or a glass, left eye green goggles or a green glass. So that's all right and red. That's no the name of the goggle. It's called Armstrong goggles. It's called Armstrong goggles. That is called, which can be used for even Diplopia charting and all. It's called Armstrong goggles. One eye has got red. Normally we apply red in front of right eye. The left eye green. We put the glass, red and green goggles. Understand now? What happens now? At a distance of 6 meters, even for near also, you can have Worth-4 dot test. That's different. But normally, I will only one Worth-4 dot test. We have got Worth-4 dot test for distance at 6 meters. We can have a picture like this. A red color will be there. The green, and white. These are all the charts there. That is a box is there. They will have illuminated. These colors will be there. So now, if you have a normal person, if you're a normal person, he's having a red goggle in the right eye, red glass, and the left eye green glass, he will see the red. Definitely one right eye will see the red, and the left eye can see the green, and the white color will be seen as a mixture of red and green. Sometimes the red may be there, something like that, but usually it's a mixture of red and green. So naturally, a normal person without any squint, he will see 4 lights. 4 lights, never forget. Then in this case, how do you know he's having abnormal retinal correspondence? How do you know this test can be used to find out abnormal retinal correspondence? Your answer is, sir, now patient is having squint. Patient is having squint. Manifest deviation is there. I put the glass and ask him to see the test. I'm doing this test. He will see still 4. Because he's having crude binocular vision. The abnormal point in the other eye will behave like a fovea for this fellow. So naturally, even though it's falling on the abnormal point, he still sees 4 instead of diplopia. That is called this test in the presence of. Now, how to tell is having ARC or not? How to tell? Your answer is, sir, in the presence of manifest deviation. In the presence of manifest deviation, in Worth-4 dot test, if the patient tells only 4 lights, that means he is having ARC. If he's having squint, otherwise a normal person will see 4. Suppose the fellow tells you, sir, I'm seeing only red only. I can see red only. That means the left eye is suppressed. And that fellow is telling, sir, I see only Green only. I see green only. That means what? Right eye is suppressed. That means you can find out suppression in this case also. Or I can suppose I see 2 reds and 3 greens. He's having double vision. And depends upon the right eye. Suppose the red is in the right side only. The green is the left side only. That means what? It's an uncrossed double vision. Uncrossed. Whereas suppose the red images have come to my left side, and here, because you never forget, I'm wearing red in front of right eye. These are cross diplopias. That means what? I can find out in a Worth-4 dot test whether he's having ARC or not, or which eye is suppressed, whether right eye is suppressed or left eye is suppressed, or double vision is there, is a cross diplopia or uncrossed diplopia. Everything can find out the Worth-4 dot test. This is one of the tests for your suppression as well as for ARC. One more test is there. This is called Bogolian-striated glasses. These do not have any power. These glasses do not have any power. They are all only striations. You can see now striations in this case. So these go, imagine now is 135-degree orientation. Here is about 45-degree orientation. When a light is seen through that, you can see a line. You can see a line, but the line will what? Because it's 135, so it's 45 degrees, I can see a line like this. And here I can see a line like this, always perpendicular to the orientation of the lines in the glass. That means I wear, suppose, right eye and left eye these glasses. I can see 2 lines like this. I can see a light is shown, Bogolian-striated glasses patient is having, and you can see a perfect cross like this. If you're a normal person. Same thing now with ARC, abnormal retinal correspondence. He will see a same thing line, like same cross can be seen in the presence of, here also you must tell, sir, in the presence of manifest deviation. In the presence of manifest deviation, patient tells a perfect cross, like a normal person, he's having ARC. Or I can have, these are all, these are what Bogolian-striated glasses. You can see now cross striations, and the striations orientation is axis, and striation orientation is axis. You know the axis now here. Understand now? But these are all, please remember, these are all actually power is there. It's not cylinder. It's just for knowing only I tell you the axis. So just know this. These are a cylinder only, but it doesn't matter. Just I will tell you, this is the orientation. The line is like this. That means it's 45 degree. This 135 degrees. Like that I'm showing. But the same striations you can see, I can put in front of the right eye or left eye, different angles. In the different axis, I have to put the glasses, the Bogolian-striated glasses to be put like this. Now, what happens now? In a normal person, a light is shown. If normal person, he will see a perfect cross, because one eye has got a 45-degree line, 135-degree, and they got a 45-degree line. So perfect cross. ARC is having squint. In the presence of deviation, still the patient tells you perfect cross is having ARC. Okay. Now there are results can be, results can be manifesting like this. Now is a perfect cross I told you. This is what normal or ARC, abnormal correspondence. Suppose they are separated like this. He's having double vision. He's having double vision. Suppose one thing is not seen. That means one eye is suppressed. One line is not there. That means that eye is suppressed. And suppose having one eye got a gap is there. One gap is that's called suppression scotomas. Small suppression scotoma is a classical feature you can see in the case of ARC. Small suppression scotoma, non-seeing area, can be seen in the ARC eye. That is, you are supposed to know. Okay. These are all the various results you can see. Hope you understood something in this case. Now I can use some macular after image test. I will have a rod, something like this, or a light is the light source, and I can have a gap or a dark area. What I will put now, I will project this light. This I can rotate this light. Now imagine now I put the rod like this horizontally. So the light is the light source, and then a dark color here. I project in front of the normal eye. I project in front of the normal eye. The other eye is closed. The squinting cavity closed. And the dark room, you have to test. And the light is shown for 10 to 20 seconds. Illuminate the retina, because this center point will fall in the fovea of the normal eye. Now, remember now, I am covering the normal eye. The squinting eye takes up now ARCI. You're suspecting ARC. Already told you, when you cover the normal eye, the ARC eye will take a fixation. The fovea is working. Now I will make what? I will make a vertical, this light with a dark area here. I stimulate that right eye, not the right, a squinting eye, or the ARCI. I am stimulating because this vertical light will fall on the squint ARC. That point, understand now? Is going to fall on the fovea of the ARCI. Is going to fall on the fovea of the ARCI because we have covered the normal eye. I already told you the fovea will take a fixation when you cover the normal eye in ARCI. So naturally, when you cover the normal eye, ARC is taking fixation. Now this light, vertical light, is falling on the fovea of the ARCI, squinting eye. Now you ask him to draw the after images. You ask him to draw the after images. All these things tests are done dark room. By you have to draw like this. You have to show, say this is your normal eye image. Tell him. You put like this. This is the normal eye after image will be like this. Ask him to draw the ARCI, understand of that eye image. A normal person, because of is falling in the fovea. The fovea of the normal eye. Fovea of the normal person, both foveas will be stimulated. So fovea will have same visual directions. So naturally they will seeing a perfect cross like this. They will put the gap will be here. The gap will be here. Now again is now here. ARCI was stimulated now. You are asking him to draw them after image. You are going to ask him to draw the after image. What will happen now? I'll tell you what will happen. Because you have stimulated the fovea of the ARCI, once you open both eyes, uncovered, what will happen now? The fovea, it is squint test come into place. The eye is going to squint. Naturally, the fovea will be somewhere else. It will be looking somewhere else. So naturally, wherever his fovea is looking, he will draw the after image of that squinting eye differently. Not in the center. He will draw somewhere here. Because his fovea is looking here. Or if fovea is looking here, that means he will draw like this. So naturally, a normal person will draw like this, because both foveas are looking in the same area. Whereas once both eyes open, the squinting eye, which has got ARC, during covering, he was also fixing with the fovea. Now, after uncovering, what happens now? The ARC has turned out or turned in or out. So naturally, the fovea will look somewhere else. He will draw the picture like this. Okay, this is a way of finding out ARC in a patient. It is called after image test of Bilskowski. It's called Bilskowski. Understand now? It's called Bilskowski test, or at least know this after image test. What you are stimulating now? Fovea. So both foveas are going to stimulate. It's called fovea macular test of or after image test. Macular after image test. This test you can easily understand is not difficult. One more thing is there. We got ARC is there. I can find out even with synoptophore. Synoptophore instruments are used. Synoptophore instruments are used to find out the ARC is there or not. And the ARC is harmonious. That means what? Completely, you know, I tell you what is harmonious. Okay, fully corresponds to strabismus. The squint completely is very useful. That means the crude binocular vision is there for the patient. That's called harmonious. Now I'll tell you what happens now. In the synoptophore, we have got, I think you might have seen synoptophores. We have got viewing tubes and all. Now we have got various degrees of binocular vision is there. You know, first grade, simultaneous perception. What I will put now, in the right eye, suppose squinting is there, and the left eye normal. I put the slides. This is called first grade vision. That's the slides. Binocular vision, first grade slides. What is that? I will put a cage and a parrot. It's a simultaneous perception. If you're a normal person, because the foveas are looking at the slides, now you will tell, sir, parrot inside the cage or something. You will tell. You cannot fuse, but you will tell in relation of this cage is there, parrot is there. Okay. Now imagine now how do you find out ARC now? Imagine now he's having squint. Imagine he's having squint. Squinting eye is there. You are going to see through the tubes. The squinting eye will see, suppose, parrot. The normal eye will see the cage. Now this fellow is also telling, sir, parrot cage, easily they are inside only. There are no deviations. That means he's having, in the presence of deviation, he's having deviation, but he still immediately tells you he's having a parrot and cage together. Okay, that is called ARC. But here now, he has not moved the arms. He has not moved the arms to bring out a parrot and everything. Parrot in the cage. So normally what happens, fovea is there, he can easily fix. Now he's having the synoptophore instrument is there. You can move the arms. By chance, without moving the arms, the patient is telling, sir, I can see a parrot and a cage immediately. No need to move the arms. He's having, please remember, it's called subjective deviation. It's called subjective angle of squint. Subjective. Patient himself is having squint, agreed. Now he's not moving the arms, but still he tells you, sir, initially, beginning itself, sir, bird and cage are there. Bird is inside the cage. That means what? Subjective angle of squint is 0. He has not moved. Now imagine now, from outside when you see the person, you know the eyeball is deviated. Now I move the arm in such a way. I will start putting lights and all. I want to see the target that is falling in the center of the cornea or center of the pupil. Then to the cornea, I move the arm in such a way the light falls on the center of the cornea. How many degrees I moved is the objective angle of squint. That means I have found out the angle of squint. So first, bird cage is there. Now normal person will see bird and cage. Okay. Now ARCI is having, if suppose the fellow tells you, sir, he is not moving the arm. Just now arm is straight, 0 degree only. Now he is telling bird and cage are inside, sir. His subject is called subjective angle is 0. Now I move the arm. I start putting light and all. Naturally, I can see the center of cornea. The light is coming till the point I move the rod. Till that extent, I have to move the rod. So that what? Move the arm, not the rod, arm. So that the light will fall in the center of the cornea. How many degrees I have moved? Okay, that is and to bring the light on the center of the cornea, that is the objective angle of squint. So I have got two things now, subjective angle and objective angle. Okay, objective angle I found out. Subjective angle, patient himself, without moving the arm, is subjective angle 0. See now, objective angle is, suppose, imagine 40, subjective angle 0. The difference how much? 40. So objective minus subjective is 40 only. 40 minus 0, so 40. This is called angle of anomaly. This is called angle of anomaly. What is angle of anomaly? Is the difference between objective angle and subjective angle. What is subjective angle? The patient was seeing the bird and cage in the target, that is called subjective angle. The angle at which he is going to put that bird in the cage. But in this case, now I told you, first case now, he has not moved the arms. The 0 degree still that fellow is putting. So naturally it's called subjective angle is 0. Angle of anomaly is 40. So difference is 40. Angle of anomaly is 40. Objective angle is 40. Please remember this. Angle of anomaly now is equal to objective angle. By chance, imagine now, by chance, first your patient has got squinting eye, he is not seeing the bird and cage in the same area, but he's having squint. Now he starts moving the arm. But imagine now at 10 degree, after movement of moving the arm for 10 degrees, he's putting that, okay, bird and cage, look at that, in the same area. That means what? His subjective angle is 10. Initially it was 0, I told you. Now he's moving the arm to put that bird and cage in the same place. That means what now? His subjective angle is 10 degrees now. But objective angle I found out. Again, I find out the objective angle. That means 40 degrees. Imagine now. So subjective is 10. Objective is 40. Now angle of anomaly is 30 only. The difference. Always remember, when subjective angle is 0, that means angle of anomaly and objective angle is equal. That's all everyone knows. Now what's happened now? This is called harmonious ARC. What is harmonious ARC? Fully corresponds to stubborn stress. Provides a compensation for the angle of deviations. Okay, that is what the angle of anomaly is equal to objective angle. I told you that's called harmonious. What is non-harmonious? In the second case, I told you subjective angle is 10. It's not 0. That means angle of anomaly, the difference between 40 and 10 is 30. Angle of anomaly is not equal to objective angle. Objective angle is 40. Angle of anomaly is 30. It's not equivalent. So naturally, what happens now? It's called harmonious, non-harmonious or unharmonious. Okay, just know this. This is the classical thing you're supposed to know. They will ask in exams, what is harmonious ARC? This is something corresponds to ARC, something fully developed, something like that. It's very useful for the patient. You can have crude binocular vision, agreed. Non-harmonious, please remember the subjective angle is not 0. He has to move the arm of the sign up to 4 to put the bird and cage. How many degrees he has moved to see the bird and cage? That is called subjective angle. Okay, so these are all objective angles, subjective angles. These are all ARC. You are supposed to know what is harmonious, what is non-harmonious, and all. ARC, I told you, fully corresponds to the strabismus. You can see a very good something, you know. Of course, binocular vision is there, agreed. I hope you understood something in the patients with adaptations and all. If next class, I will tell you something about the motor adaptations. Motor adaptations in the case of squint to avoid diplopia, other things. Thank you very much.